Maillard reaction is an important reaction which is responsible for color and flavor in foods. There are different pathways in these reactions, and Strecker degradation is one of these pathways where amino acid is decarboxylated and deaminated to form an aldehyde which is called as Strecker aldehyde. Adolf Strecker in 1862 observed the formation of acetaldehyde and isovaleraldehyde in reactions of alloxan with alanine and leucine respectively. The term Strecker degradation was originally proposed for reactions induced by carbonyl compounds, but nowadays it refers to many other types of oxidative deamination. Transamination involved in the reaction yields aldehydes, aminoketones, and carbon dioxide. The Strecker aldehyde and aminoketones formed are responsible for strong odors. Let us have a detailed look at the mechanism.
Okay, now let's get into the part 2, the basic mechanism of Strecker degradation. At the whole process of a Maillard reaction, there are about 9 steps to form different cooked aroma that improves their flavors. In this case, one of the main reactions in this picture, which refers to the R7, 8, and 9, is the Strecker degradation. Based on the evidence to date, it probably takes place by the mechanism shown below, like that. Usually, it is a reaction between the free amino acid and their carbonyl components that derived from the Maillard reaction pathway and produced an aldehyde and aminoketone. Therefore, our understanding was based on observed products like carbon dioxide, aldehyde, and so on. Often, carbohydrate dehydration products and their fragmentation products provide the alpha carbonyl reactant. One advantage of the using reactive carbonyl components is that it may be possible to produce cooked aroma even at relatively low temperature. During the reaction, the amino acid undergoes decarbonization and deaminase and transfer into the imine or substrate base. This reaction is compound with the carbon oxide double bond is replaced by the carbonyl nitrogen double bond. Mechanically, the formation of it involves 2 steps. After that, a strictly relative aldehyde, termed Strecker aldehyde, contains 1 less carbon atom than the original acid is formed, which contributes to the formation of the cooked aroma. To sum up, the Strecker degradation plays several roles in the formation of the flavor components in processed food. You can see from the picture, like that.
We have gone through mechanism of Strecker degradation, and now we wonder when the Strecker degradation occurs. Strecker degradation occurs when there is presence of high free amino acids in food, or it can happen under more extreme conditions such as higher temperature or under pressure. There are some conditions that could form compounds other than Strecker aldehyde and aminoketone. Let's look at examples below. When there is presence of oxygen, the intermediate product formed of the hydration and decarboxylation steps are not able to form Strecker aldehyde and aminoketone. Instead, the intermediate product will undergo oxidation to form alpha dicarbonol and followed by intramolecular redox reaction and hydrolysis to produce Strecker acid and aminoketone. Examples of Strecker acids are acetic acid that comes from alanine, or 2,3-metabutanoic acid that comes from leucine or isoleucine. Another condition would be when the food system has low water activity, the intermediate product prior to the release of Strecker aldehyde and aminoketone cannot be produced. The process eventually forms 4-oxazoline, which is also in equilibrium to 3-oxazoline. However, Strecker aldehyde can be released from oxazoline upon addition of water. The formation of oxazolines via Strecker degradation can be found in cooked meat and roasted peanut. Both Strecker degradation products, aminoketone and Strecker-aldehyde, can further undergo an array of reactions that lead to formation of important aroma compounds. Now let's look at the first Strecker degradation product, aminoketone, on contribution to the food aroma. Aminoketones produced from Strecker degradation, they can further react by undergo condensation and form dihydropyrazine. Subsequently, it undergoes oxidation to produce pyrazine. Pyrazine can be found in food products such as baked and roasted food.
Strecker degradation plays an important role in the flavor formation of various processed foods. This reaction converts amino acids into the related aldehydes, which contribute significantly to the aroma of final products. Some processed foods having Strecker degradation include meat, milk, cheese, cocoa, black tea, and beer. In this video, we will focus on meat, cocoa, dairy, and beverage products. Raw meat contains precursors for the formation of aromatic molecules such as sugars, amino acids, ascorbic acids, and thiamine. Via cooking, many reactions, including Strecker degradation, occurs to form aromatic compounds. In Strecker degradation, different amino acids will produce different products. Common amino acids are alanine, valine, leucine, isoleucine, methionine, and cysteine, which forms respective products include acetaldehyde, 2-methylpropanone, 3-methylbutanane, 2-methylbutanane, phenylacetaldehyde, methionine, and acetaldehyde, mercaptoacetaldehyde with different aromas. Methionine and cysteine are two most important amino acids in the formation of meat aroma. Methionine produce methionine with the aroma of baked potato. 2-propanone and methantion are formed from the methionines, which are on reactive intermediates participating into further reactions to form various final aromatic products. Cysteine produces a number of highly reactive intermediates with flavors generating potential such as ammonia, hydrogen sulfide, acetaldehyde, and mercaptoacetaldehyde. The flavors of cocoa products are affected by different factors such as genetics and growing conditions, processing stages including fermentation, drying, and roasting. Cocoa is a source of Strecker degradation with the reducing sugars, amino acids, and flavonoids. Major amino acids are leucine, phenylalanine, threonine, isoleucine, in which leucine and phenylalanine are the two most important amino acids, with isovaleraldehyde and phenylacetaldehyde as main products. Furthermore, threonine produces acetaldehydes involving in more complex reactions.
Now I will briefly talk about the contribution of Strecker-aldehyde to the flavors of processed milk. As you can see, this table shows some Strecker-aldehyde detected in some types of milk. Well, 2-methylbutanol formed in Strecker degradation of isoleucine was found in pasteurized, sterilized, ultra-high temperature treated milk and milk powder. Another aldehyde, 3-methylbutanol, which was generated from leucine, was detected in pasteurized and sterilized milk. And another one, isobutanol, which was generated from valine, was found in ultra-high temperature processing milk and milk powder. Well, aside from processed milk, cheese is another dairy product that contains Strecker-aldehydes. 2-methylbutanol, 3-methylbutanol, 2-methylpropanol, acetaldehyde, phenylacetaldehyde, and methionol are common Strecker-aldehydes that can be found in cheese varieties. Among them, the first three aldehydes can contribute to the nutty flavor in aged cheddar cheese. In Parmesan cheese, 3 of them combined with acetaldehyde and phenylacetaldehyde can contribute to the formation of a sharp, penetrating, and fruity flavor during the cheese ripening. In addition, In switches, some Strecker aldehydes were also detected, including 2-methylbutanol, 3-methylbutanol, 2-methylpropanol, phenylacetaldehyde, and methionol. Well, besides from the contribution to flavor of some dairy products, Strecker aldehydes also contribute to the aromatic spoilage in alcoholic beverages. The accumulation of methionol and phenylacetaldehyde in beer during the storage can lead to the aromatic deterioration. The Strecker degradation in beer can be accelerated by temperature, so the higher storage temperature will result in faster Strecker degradation. So that to increase the shelf life beer, the storage temperature should be controlled. On the other hand, Strecker aldehyde was also found in wine. They contribute to the wine spoilage by decreasing the freshness and induce the up-odor development. The formation of Strecker aldehydes in wine is affected by temperature and the level of dissolved oxygens.
The Strecker degradation of amino acids has emerged as a seemingly endless source of flavor significant compounds since its discovery almost 150 years ago. Maillard reaction is related to pleasant flavors. How about the lipid oxidation? Lipid oxidation is responsible for the rancid flavors during storage. The question is, can the Strecker products be formed due to other pathways as well? Today, Strecker and Strecker-like reactions encompass a much wider range of food components, including lipids, lipid oxidation products, and polyphenolics as well as terpenoids. A study was conducted in 2004 to clarify if there is any contribution from lipid oxidation products to Strecker degradation of amino acid. They analyzed the reaction of 4,5-epoxy 2-alkenyls with phenylalanine. The data in the study indicated that the Strecker type degradation of amino acids is produced by some lipid oxidation products. Further studies are conducted to see how different reactions can be coordinated to form flavor compounds. There are evidences confirming the relationship between Maillard reactions and lipid oxidation reactions. The experiments on Strecker-like pathways in lipids suggest that both reactions should be studied together to understand the mechanisms in complex food systems. Extensive researches and exploration is going on in the field of amino acid carbonyl chemistry, especially with the development of advanced technologies for research. And more often, the Strecker-like reactions are being considered not only as source of aroma compounds, but also as contributors of visual chromophores and as chase components as we have seen before. Thank you.